Okay, so here it is. Power of a power. Read that to yourself a few times because it can be confusing if you break down each and every word. Power of a power. In this case, the first word power is talking about the actual exponent. Okay, so you know me, I like to break it down. We're talking about the exponent part. Of translates to what algebraically? What algebraic operation does of represent? What do we do? Multiply, and we use parentheses for multiplication. The exponent multiplied, or the exponent of a power that already exists. Now you need two parts to create a power. What two parts? A base and an exponent. So if we're talking about the power of a power or the exponent of a power, put together, it would look like this. Here's my power that already exists. What do we do, or what law, what rule do we apply when you already have a power and you raise it to another power, or you raise it to another exponent? Okay. Looks a little bit different than what we did yesterday, because yesterday we had two separate powers and each of those had their own exponents. Today we have one power. I'm going to label it like this. You have one power. I'm going to change a few different colors. The parentheses is what gives us our of part. And that 3 is our exponent. So the question today is, what do we do with the exponent of a power that already exists? The exponent of a power that already exists. Okay, what are we going to do with it? And I believe I put my notes away. Give me a second. Where's my notes? All right, so let's figure out the hard way or the long way. What happens when we have this rule? First thing we want to do is we're going to expand the inside of the parentheses. When we expand 5 squared, remember 5 squared is not saying 5 times 2. It's saying that you're multiplying what times what? 5 times 5. Now, because we have that exponent on the outside, they want us to create 3 more groups of 5 times 5. And that's where all of these come from. Group 1, group 2, group 3, exponent 1, 2, 3. Now, once again, I told you guys yesterday, it doesn't matter if it's parentheses or dots. Both parentheses and dots in between these numbers represent multiplication. So you could easily have half of them with parentheses and the other half with dots. They all represent multiplication. We're multiplying that 5 essentially how many times? 6 times. 5 to the power of 6. Once again, it doesn't matter if you have dots or parentheses. It's multiplying that 5 over and over and over again. So 5 to the power of 6. Let's look at the next one. We have x to the power of 3, or x what? The power of 3 has a special name. What is it? Cubed. So if I were to write out x cubed, how would you write that out inside of the parentheses? X what? You multiply the x, you multiply the base this quantity of times. You multiply the same base, that x, this many times. But notice we do have that exponent on the outside. They want us to multiply that base they want 4 more groups of these 3 x's. So I have to create 4 more groups. So we're going to have a group of 3 over here, x times x times x. We're going to have a group right here, x times x times x. A group here, x times x times x. And a group way over here. Too many x's, okay? So how many times, once again, doesn't matter if it's dots or parentheses, we're still multiplying the same base over and over and over. How many times did we multiply it in total? I mean, multiply it, yeah. How many times did we multiply that x in total? How many x's do you see there? Not 9. There's 4 groups of 3. 12. Count them out, 12. 12, okay? So just like yesterday, for that number 1 question, it's asking us to compare, and it should say row instead of column. We're still comparing that first row with the last row. This part here in the middle, it just shows us where these numbers are coming from. Why our numbers are increasing, why our numbers are getting so big. How did they get so big, okay? So, what are the similarities? What are the differences? If there is a difference, how did we get there? So from 5 squared to the power of 3, we got 5 to the 6th. From x cubed to the power of 4, we got x to the 12th. What stayed the same? What's still similar? The base, same base, same base. Base stayed the same. What didn't stay the same? What changed? What changed yesterday? The exponent. So what do you think is going to change today? How is the exponent changing though? Because yesterday we were adding those exponents, but if I add 2 plus 3, I don't get 6. If I add 3 plus 4, I do not get 12. So how are these exponents changing? What's happening? They're being multiplied. 2 times 3 is 6. 3 times 4 is 12. So this time, instead of adding, we are going to multiply, and we will compare the difference between the two in a little bit. So multiply the exponent. Emphasis on exponents. Once again, laws of exponents. It's in the name, the laws, the rules, they apply to the exponents only. This addition, this multiplication, we're manipulating, we're changing the exponent, not the base, okay? Now, this is the formula that you're gonna see on the formula chart on the STAR test. Let's compare it to the one that we saw yesterday. So I'm gonna just do a little verses over here. Yesterday's formula looked like this. A to the power of m times, and it probably didn't show parentheses and it didn't show a dot, but I like to show it in parentheses, a to the power of n. When you're multiplying 2 powers, remember, to make a power, you need a base with an exponent, base with an exponent. Multiplying 2 or more powers, what do you do with the exponents? You add them. Base stays the same, but you add the exponent, m plus n. But look at the difference between what we're gonna do today and what we did yesterday. Here you have 2 separate powers. They have the same letter, they have the same base, but here you only have how many powers? 1 power with 2 exponents on it. Here is 2 powers, each has their own exponent. Here you have 1 power with 2 exponents. So when you have 1 power and 2 exponents, what do you do with the exponents? You multiply them. So m times n. And when you're ready, go ahead and flip that page, m times n. We are going to take that outside exponent and multiply it by the exponent inside. I want to say, I'm always, hey, I got it this time. All right, cool. So power of a power. What do we do with the power, or what do we do with the exponent on the outside? I'm going to zoom in really, really big. Here we go. That way everybody can see. All right. And I'm going to repeat myself over and over and over again. You're probably going to get sick of hearing it, but it'll be okay. This is always the hardest lesson, and I feel like this helps. I'm tired of wearing my glasses. All right. What do we have inside of the parentheses? We have a squared. We have a power. When we have one power with two exponents, what do we do with the exponent? We multiply. We take that outside exponent and distribute it or multiply it with the one that's on the inside. So it becomes a to the power of 2 times 3. Okay. And 2 times 3 gives us 6. Once again, just like yesterday, you have to write in that extra step. If you don't want to do it on your homework and miss the assignment, that's on you. But I want to see all the steps in my notes. Ready? Let's look at the next one. Inside the parentheses, we have how many powers? Just one power. Now, in order for it to be a power, it needs two things. It needs a base and a what? Z does not have an exponent. So what exponent do I assign? A 1. Now that I have one power with two exponents, what do I do with the exponent? You distribute it, you multiply. Oh, what is this? Okay. So Z to the power of 1 times 2. And 1 times 2 gives us 2, Ms. Ramirez. Okay. Now, the exponent of 2 has a special name. What special name did we give it? Squared. Squared. Questions on this one so far? Both of the lessons from yesterday and today are they're crucially important. They are very, very important because if you don't understand these two, you're going to be completely lost starting tomorrow or maybe Monday. We're Monday here, right? Yeah, it's the following Monday we're. All right, here we go again. How many powers do you have inside this group of parentheses? How many different bases do you see? There's 2 different bases. What 2 bases do we have here? The 3 and the X. Here's my 2 bases. In order for them to be powers, they both need an exponent. Which one's missing an exponent? The 3. So let's go ahead and put a 1 there. Now, since I have 2 powers, that means I'm going to have how many groups? 2. Now, we practiced this a little bit yesterday, but in order to make this a little bit simpler or to look less messy, we were splitting those powers by category. Now, the first category is that 3 to the power of 1. Now, the rule here, since it's in parentheses, you're going to keep it in parentheses. If the power is in parentheses, keep it in parentheses. The powers yesterday were not in parentheses, so you didn't have to, but they are today. I'm going to go ahead and circle that 6 so I don't forget about it. But the first power is what? 3 to the power of. And what is the exponent that belongs to that? On the outside? 6. Now it should look a little bit easier. 3 to the power of 1 to the power of 6. 1 power, 2 exponents. What do we do with the exponents? You multiply them. Now, I'm being super repetitive because by the end of the lesson, you're going to see what happens when you're combining yesterday's rule with today's rule. So 1 times 6. And what is 1 times 6? 6. Now, on the STAR test, I went over this yesterday. They could either leave their answer in this form or they could take it a step further. Type in 3 to the power of 6 in your calculator and tell me what it gives you. Because mine is not, oh, there we go. Oh. 729. Remember, you use this little button under the clear 1, and it'll give you that little box up there. It's called a caret. I know it doesn't look like one, like the vegetable, but that's what it's called, okay? All right, let's go back. So 7, ooh, wrong color. 729. Now, after I get that 729, there's nothing else I can do with this side. Moving on to the next group. What is the power of the second group? X to the power of 4. But this also has an exponent on the outside of 6. Okay. You have one power with two exponents. What do you do with the exponent? You multiply them. So it becomes x to the power of 4 times 6. And I think this is the part of the video that I left out. So that's why I'm redoing this video. It was this step right here, because I think I did show this. So 4 times 6, and 4 times 6 gives us 24. And I stopped there. It doesn't matter that this one took extra steps. I don't have anything else I can do here. So once you're done simplifying or reducing every group, put it back together. 729, x to the power of 24. That is your final answer. Questions? All right. Look at example D. How many bases do we have? There are 3 bases, meaning we're going to have 3 different groups. Now, some of those bases are missing exponents. Which ones are they? The 3 and the A. So make sure you assign a what? If a base is missing an exponent, every number, every letter, every big number, and every letter has to have its own exponent. Now I'm going to go ahead and circle this 4 on the outside so I don't forget about it. In the first group, what is my power? Three to the power of. And what is the exponent that I need to write on the outside of it? Okay, so 1 power with 2 exponents, you distribute, you multiply the exponent. Becomes 3 to the power of 1 times 4, and 1 times 4 is, okay, now take it a step further. Let's go ahead. That way we're able to recognize it both ways. 3 to the power of 4 gives us what? 81. Done there. Next group. What is the next power? A to the power of 1. And what exponent do I need to write on the outside of it? Now, when you have 1 power with 2 exponents, what do you do with them? Multiply. So 1 times 4. And 1 times 4 is, can I do anything else? All right. Next group. What is the last power in the parentheses? B what? Squared. Let's use our terms. Squared. What exponent do I put outside? 4. 1 power, 2 exponents, multiply. In the next line, b to the power of 2 times 4. And 2 times 4 gives us 8. Once you're done simplifying or reducing every group separately, go ahead and put it back together. 81, a to the power of 4, b to the power of 8. That is your final answer. It helps when you separate the groups. Because if not, you have to distribute the exponents and do all that stuff in your head. And that sucks to me. Ready? Questions so far? All right. How many powers are in the next group? 2. So how many groups are we going to have? 2. Now, every power has, or every base has its own exponent. So I'm just going to circle this 2 over here to make sure I do not forget about it. The first power inside of the parentheses is what? Is what? Squared. And what number on the outside, or what exponent? Another squared. We have 1 power with 2 exponents. You multiply the exponents. 2 times 2. And what is 2 times 2? 4. S to the power of 4. Second group. What is the second power? R cubed. What exponent on the outside? 2. When you have one power with 2 exponents, you multiply them. So we're going to take r cubed out and multiply that 3 times, not 3 times 3, 3 times 2. My bad. I'm tired. And it gives us r to the power of 6. Once you simplify each group as much as you can, put them back together. S to the power of 4, r to the power of 6. Whew. Questions on this one? How many powers on F? How many groups? 2. Now, each power already has an exponent, so all I have to do is worry about circling that outside one so I don't leave it behind. Okay, so here we go. The power of the first power inside of the parentheses is 2 cubed. What do I put on the outside? 5. You have one power with 2 exponents, so you do what with the exponents? Multiply it. So 2 cubed times 5, and 3 times 5 is 15. Remember, this 2 to the power of 15 does not represent 2 times 15. So go ahead and type that into your calculator. They are not the same size. They are not treated the same way. What do you get? $32,768. We've now gone as far as we could with this one. What is the second power? With what on the outside? Okay. So I'm going to take this 5 and we are going to multiply it. One power to exponents, you multiply them. 2 powers to exponents, you add. 2 times 5. So we get w to the power of 10. Once you can't go any further, you combine it or put it back together. So 32,768 times w to the power of 10 is your final answer. And just like on your assignment, on the STAR test, they might ask you for the coefficient. They might ask you for that 32,000, or they might ask you for that exponent. You just got to be careful. What is the difference between the examples that we've just completed and this one? Where? On what part of my power? On the base, correct. On the base. I'm going to write a little note here. When your base, or if base, all caps, has parentheses, leave it in parentheses. If the base has parentheses, if the base has parentheses, leave it in parentheses. No, I don't like that. If the base has a negative, if the base has I'm just gonna put a negative. If the base has a negative, leave it in parentheses. If the base has a negative, leave it in parentheses. Okay, here we go. Now, that base of -2 doesn't have an exponent, so I'm going to go ahead and put a 1 there. I'm going to circle that 3 so I don't forget about it. The power, the first power in the parentheses is what? -2 to the power of 1. What exponent do I write on the outside? The 3. When you have one power with 2 exponents, what do you do with the exponents? You multiply them. Okay, now because my base has a negative, I'm going to leave that -2 inside the parentheses and bring this 1 out to multiply that one by the 3. And really what's affecting it is the exponent, whether it's a positive or a even or odd number, I think. Okay, now 1 times 3 is what? 3, so -2 to the power of 3. And what does that give you? -8. Awesome. All right, what's the second power inside of the parentheses? X squared. And what do I write? What exponent on the outside? When you have one power with two exponents, you multiply. So we get x to the power of 2 times 3, and 2 times 3 gives us 6. Nothing else I can do there. Once I'm done reducing or simplifying, put them back together. -8, x to the power of 6. Okay. Now that was the part that was supposed to be in the video, but obviously since nobody watched the video, I'm hoping 1 or 2 of you watched the video last night, but since nobody watched the video really, let's go ahead and continue with the next few examples. I think we're only going to be able to get all the way to E. Ready? Questions so far? No? Okay. I think it's all the way at the top. Yeah, it's this one. All right, here we go. How many powers inside of the parentheses? 2. Don't forget to fill in your missing exponents. I'm going to circle that 9. That way I don't forget about it. The first power in the parentheses is what? 7 to the power of 1. What's on the outside? The 9. Okay, so when you have one power with 2 exponents, you multiply them. So 7 to the power of 1 times 9. And 1 times 9 is 9. Now, this is the one that's going to give you the very big number. So let's see if y'all know how to pronounce that. What is it? It's not going to give you squared.
4,035,000. No. No.
Try again.
40,353,000.
There you go. Took you a minute, but it's okay. Proud of you. All right. 40,353,607. Yes. Don't be lazy. You were already lazy to not watch the video. All right. What is the second power? D to the power of 4. What do we put? What exponent on the outside? 9. Oh, don't be getting aggressive. It's not my fault. Y'all didn't watch the video. So D to the power of 4 times 9. And what is 4 times 9? 36. Once you can't go any further, put it back together again. So yes, Hillary, you do have to write all these numbers all over again. 353,607 times D to the power of 36. Ready? I have no idea why a chair would be comfortable enough for a nap. All right, how many powers inside here? 2. 1 missing exponent, so make sure you fill that little part in. We have an exponent outside, circle it so you don't forget. I have to be careful because of what? Thank you. The base has a negative. So the first power is what? To the power of? Remember, when I'm asking for the power, I'm asking for the base with the exponent. What exponent on the outside? Now, when you have one power with 2 exponents, what do? All right. Now, because my base has a negative, make sure you leave it in parentheses. On the outside, I'm going to multiply 1 times 5. What is 1 times 5? And what is -3 to the power of 5? Awesome. -243. Okay. What is the second power in the parentheses? And what exponent do I write outside? When you have one power with 2 exponents, you multiply. We're almost to the point where you're going to have to add yesterday's rule. I don't know why I wrote another parentheses. 2 times 5, and 2 times 5 is 10. Once you can't take it any further, go to the bottom and put them back together again. Negative 243 p to the power of 10. Negative 243 times p to the power of 10. Yes, we will be combining the rules. There's 7 different rules that we're going to combine by the end of next week. Or by the middle of next week. I'll see you in tutorials. She said, okay. Ready? All right. C. How many bases or how many powers do we have here? 3. Make sure you fill in all of your missing exponents and circle the one on the outside if there is one. All right, the first power is 2 to the power of 1. What exponent do we write outside? 2. 1 power, 2 exponents, you multiply. So we end up with 2 to the power of 1 times 2. 1 times 2 is 2, and 2 to the power of 2 is what? 4. Or 2 squared is 4. 2, 2, 2, 2, 2, 2. What is the next power? What exponent on the outside? Because you have 1 power with 2 exponents, what do? And 3 times 2 gives us? All right, that's all we can do with that one. What is the last power in the group? Okay, and what do we write on the outside? 1 power, 2 exponents, you multiply. I know I sound like a broken record. So x to the power of 1 times 2, 1 times 2 is? Can I go any further? No, once you're done, put it back together again. 4 times w to the power of 6, x squared is your final answer. Remember, these are all expressions. So your answers might look a little weird. You're not going to have x equals something. You're not going to have y equals something. All right, last easy one before you start seeing some that may possibly look like the ones on the STAR test. How many powers do we have here? We have 3, so we're going to have 3 different groups one more time. 1 and 1. We have an exponent on the outside, and I have to be careful with the what? Negative. My first power, negative 4 to the power of 1, has a negative on that base. Exponent of 4 outside, so make sure you are careful. Keep it in parentheses. 1 power with 2 exponents, you multiply them. The negative 4, because it's a negative base, keep it in parentheses. 1 times 4 is? And what is, this is where it becomes super duper important. What is 1 times 4? 4. Because my exponent is an even number, it's that this is where it really affects you. I'm going to move this to the side. Look and see, or look at what happens when you don't keep it in parentheses and when you do. So let's say I forget about my parentheses, negative 4 to the power of 4, it'll give you a negative. But if I keep it in parentheses, like Ms. Ramirez told me, you get the correct answer, which is a positive 256, okay? So make sure you're aware, you're careful with that. Oh, Lord. All right, what's the next group? What's the power in the next group? F to the power of 1, exponent of 4 outside. 1 power, 2 exponents, you multiply. So we get in the next line, f to the power of 1 times 4. And what is 1 times 4? Nothing else to do there. The last power is what? H cubed. H cubed to the power of 4. 1 power, 2 exponents, you multiply. Okay, so we get h to the power of 3 times 4. And 3 times 4 is correct, 12. Oh, man. Oh, man, calling each other out on my videos. That's fine. Oh, I'm still recording. Yep. Everybody's enjoying the silence. It's better to record in this class than my 5th period. I said what I said. You don't want to go in my 5th period. All right. Last one, because I don't think we'll have time for F. Here we go. I said I said all the way through E. Yeah. All right. What makes this the hardest one? It's 2 sets of parentheses, and each group of parentheses has its own exponent. But we're still going to group these the same way. We're still going to use the same process, but we're going to be careful because each group of parentheses has its own exponent. Okay, we're still going to group the numbers together. We're still going to group the same variables together. Now, there are 3 bases that don't have an exponent. Make sure you fill that in first. 5 to the power of 1, 2 to the power of 1, k to the power of 1. Now, both my 5 and my 2, those are my big numbers. Those are just my bases. They're not the same size as my exponents. So I'm going to group those together. But first, I'm going to move that 5 out of the way. So when I take that 5 out of the group, what is the power? 5 to the power of, and what exponent do I write outside of this one? 2. 5 to the power of 1 has its own exponent of 2. Now, the other power that I can categorize with this one is 2 to the power of 1. But 2 to the power of 1 does not have an outside exponent of 2. It has an outside exponent of 3. Is everybody with me so far? 5 to the power of 1 had that exponent of 2. 2 to the power of 1 had the exponent of 3. Okay? Now, it should look a little familiar. 5, you have 1 power with 2 exponents, so I'm going to multiply here. 5 to the power of 1 times 2, and 1 times 2 is 2. Now, do we treat this as 5 times 2? No, it's 5 squared. 5 times 5 gives us 25. Now, we're taking what we simplify from all of this and multiplying, because there's parentheses here, multiplying whatever we simplify from this. So I'm going to just write some big dots in between. That way I remind myself that I'm still multiplying here. 1 power, 2 exponents. I'm going to take that exponent and multiply it. So we're going to take 2 to the power of 1 times 3. And 1 times 3 is 3. What is 2 cubed? 8, Ms. Ramirez. Okay, 8. Awesome, 8. Now, I can't simply put these together and write 258 because we're once again multiplying whatever we get from this times whatever we get from this. 25 times 8 gives us 200, Ms. Ramirez. Okay, awesome, 200. Now, what is the other group that we can create? My what? My powers of k. Now, from the first group of parentheses, I'm going to grab what? K to the power of 17. And k to the power of 17 has an outside exponent of 2. Now, in the second group of parentheses, I have k to the power of, with its own outside exponent of 3. Are you with me so far? All right, you have 1 power with 2 exponents. What do? We multiply them. So we're going to get k to the power of 17 times 2. And 17 times 2 gives me what? 34. 1 power, 2 exponents. You multiply. So we get k to the power of 1 times 3. And 1 times 3 is 3 times. Okay. Now remember, we're multiplying because of this parentheses. We're multiplying what we get from this group with what we get from this group. Okay. So when you have an expression where you have to combine 2 rules, this is the first one that you're gonna do. You're gonna multiply. Okay? Now, in this step right here, and let me just go ahead and box it in with a different color. This is the step that we did yesterday. Oh my gosh, why is it not? This is the step that we did yesterday. We did it from here. What do we do here? What is the difference?
When you add because of the same base.
Correct. Look at the difference here. I've been saying it over and over and over. One base, two exponents. Here you have two powers with their own exponent. Here you have one power with two exponents. Here you have two powers and they each have their own exponent. That is the rule from yesterday. That is product of powers. So what do you do with the exponents when you have product of powers? You add them. Base stays the same, the K remains a K, and you add the 34 plus 3. Okay, and 34 plus 3 gives us, once you're done simplifying, put it together. And you're done. All right, so you're gonna finish the second half of that assignment, but you also have the video for tonight.